Hello children, in today's class we will be discussing the numericals based on law of conservation of energy. So to understand numericals based on law of conservation of energy, we will take three examples. First example, let us take it in the case of freely falling body. And the second example, we take a body which is thrown vertical upwards. And the third, the very important thing is what actually simple pendulum. Children, examination point of view, numericals based on simple pendulum are very important. So first, before going to start a numerical, let us recall what is law of conservation of energy. Children, law of conservation of energy states that energy can neither be created nor be destroyed. But what happens? It can be transferred from one form to another form. Especially children, when there is energy conversion between only potential to kinetic and kinetic to potential, then what happens children? The sum of the potential and the kinetic energy is always remains constant. But children, one condition is there. What is that condition? Air resistance must be neglected. So first, in the two examples, let us see where air resistance is neglected. Okay children, fine. Let us start the first numerical. So as per the question children, as per the question, if you can see, a body of mass 10 kg is left from a height of 10 meters. Then find the final kinetic energy attained by a body. First, let us write the data given. What is given actually children? If you can see here, mass is given 10 kg, okay, that is fine, and height is given 10 meters, okay, and g is given 9.8 meter per second square. Here some students may get one doubt. So to calculate the kinetic energy, we need to have velocity, right? Of course, you are right. So getting the doubt is nothing is wrong actually, because kinetic energy means immediately we will get a point to our mind. What is that? The kinetic energy means what the energy possessed by a body by virtue of its motion means it should have velocity. But then how to calculate the kinetic energy in this case? Children, that is what I am telling you. Let us recall once again law of conservation of energy. First, suppose children, let us say this is a point A where from the point from where the body is left, and let us see this is a point B where just it is about to reach the ground. So as per the law of conservation of energy, can I see that children? The energy at a point B must be equal to energy at a point A? Yes, obviously it is right. Here only you should write one statement according to law of conservation of energy. So what is the energy possessed by a body at a point B children? Kinetic energy. That is final kinetic energy. Final kinetic energy is equal to, you must write this statement, initial potential energy. So now let us write. So for potential energy formula, we know it, that is what? mgh. Now you substitute the values, that is 10 into g value is given 9.8 into 10. If you can substitute, you will get 980 joules. Okay children, this is how we can calculate, but strictly here air resistance is neglected. Now let us see the case children, second case here. Here what is happening? A body of mass 2 kg is projected vertically upwards with a velocity of 10 meter per second. Then they are asking us to find the final potential energy possessed by a body. Same concept here, but here initially it has kinetic energy that is converted into potential energy. For what here? Means based on what? Law of conservation of energy. So here let us write here, final potential energy is equal to initial kinetic energy. So initial kinetic energy children, half mv square. If you can see here, half into mass is given 2 kg into v value is given 10 square. 2 cancel. 10 square is how much it is? 100 joules. So children, this is how we can use the conservation of energy in order to calculate kinetic energy and in order to calculate potential energy. Just you copy this. Now we will solve the numericals based on simple pendulum. So this is the height h. Now children, so we are going to solve three types of numericals based on simple pendulum. Of course, by seeing this you may get one doubt, sir, three numericals seems to be same. How can you say that three are different numericals? That is a specialty of these numericals children. Now let us see one by one, third one, fourth one, fifth one. See children, so this is the question about third is that it is given that a body of mass m is given a velocity of 10 meter per second, so that it is raised to a height of h, and find the height h. But here the thing is that what? there is no air friction. Children, this is a case of no air friction, which means what? Whenever there is no air friction, children, so there is no loss of energy, which means what? Whatever the energy does the body have at a point A, completely will be converted into at a point B also. So as per the law of conservation of energy, children, energy at a point B must be equal to the energy at a point A. So we know that energy at a point B will be mgh. Okay, energy at a point A will be half mv square. So here mass will get cancelled. So G value it is given as 10 meter per second square. If it is given 9.8, let us take that only. So if you can see, children, here h is equal to v square by 2g. Let us substitute the values. V square means what? 10 square, that is 10 into 10 by 2 into 10. If you can solve this, you will get it is a 5 meters. Is it clear, children? Fine. Now come to the fourth numerical. How it is differ from question number 3. So here also a body of mass m is given a velocity of 10 meter per second. But the condition is that here 40% of energy is used to overcome the air friction. Try to understand, children. How much? 40% of energy is used to overcome the air friction. Then how much energy is left to be converted? 60%. It's a very important. Means in this case, the energy at a point A is not equal to the energy at a point B. These are very important. Which means what, dear children? Energy at a point B is equal to the 60% of the energy at a point A. This is a point what we have to understand. Very clearly it is said that 40% of energy is used to overcome the air friction. Means only 60% of the energy is converted. Then what will happen? Now same process you can follow. That is mgh is equal to 60%. 60 by 100 into it is half mv square. M cancel. So 0 cancel. So here G value is, let us take 10 only. The h is equal to 6 by 2 into 10 is how much? 20. And the v square is 10 into 10. 10 cancel. 0 cancel. H is equal to 3 meters only. Children, try to understand difference here. Is that clear? Fine. Now what about the fifth question, children? Here also body of mass m is given a velocity of 10 meter per second only. But here the condition is that, so very important thing is that only 40% of energy is converted into energy at a point B. Try to understand. In a question 4, what is given? 40% of energy is used to overcome the air friction. Means 60% of energy is converted. But here in a question itself, very clearly they mentioned that 40% of energy only converted, which means what? 60% of energy is lost to overcome the air friction. Then how to come on? So let us say it is a point A, it is a point B. Then energy at a point B is equal to the 40% of energy at a point A. Now remaining thing will be everything is the same. Come on, this is mgh is equal to 40 by 100 into half mv square. M cancel. Now let us simplify this here. 10 into h is equal to 0 cancel. That is 4 by 10 into half into 10 into 10. So 110 gets cancelled. This 10. So 2 ones are 2 twos are. Here height is equal to 2 meters. Is that clear, children? So this numerical seems to be same. But in a third question we got answer 5 meter. In the fourth question we got answer 3 meter. In the fifth question we got a 2 meters. Children, again I am telling you what is the difference here between these three numericals. In the third numerical there is no air friction. In the fourth question what happened? 40% of energy is lost to overcome the air friction. But whereas in the fifth question 40% of the energy only converted. So whenever the question is given, the numerical is given based on this, children, you should be very careful whether air friction is neglected completely, or how much energy is lost to overcome the air friction, or how much energy is converted into a potential energy. So if you are okay with this point, children, then definitely you can do the numericals based on the law of conservation of energy in a simple manner. Okay, children, Thank you so much.